Is my screen coming through?
Yeah, all right, perfect. Okay, Thomas is gonna talk about VR accessibility and the metaverse. Thomas,
Hmm.
take it over.
Thank you so much. Well, hello, everyone. I'm really happy to talk with you at GAD Japan today about this topic. I'm very passionate about this topic. I'm Thomas Logan. You can find me on LinkedIn and Twitter at Tech Thomas, and I'm the owner of a accessibility consulting company called Equal Entry. And you can see in my Twitter bio, I have VR, AR, XR. So it is really what I enjoy. This is just to take you back in time. This is going to start with an introduction of what VR is in the metaverse and then show real examples. In this example, this is me and my twin sister in the 1980s playing a Sega product that actually was a early version of a VR system. So one thing about VR is there have been products available even since the 1980s for trying virtual reality. And basically the definition of virtual reality VR is a simulated experience that can be similar to or completely different from the real world. So in this example on the screen, on the left-hand side, we have students in a classroom, a real classroom. And in the right-hand side, this is a virtual reality application called AltSpace, where you can actually attend a presentation just like you would attend a presentation at a real university. And one of the first devices that got me excited for VR was when Google came out with Google Cardboard. And this is to show this was a very simple piece of hardware. It was a cardboard box. You put your phone inside of the cardboard box, and then you can use the phone to see in 3 dimensions. So this was one interesting device because it's not that expensive. And when we think about accessibility, we're always wanting to consider the price of technologies as well for if that's going to be a good accessible solution. This is an example just to show how VR works with the glasses. So on the left and right, we have an image that's slightly shifted in what's called a stereoscopic view. And this stereoscopic view means that different images come to the 2 eyes at the same time. And that's how we see in 3 dimensions. So basically inside of the headset, we're seeing 2 images always being displayed. So it's like looking at 2 monitors really close. This is the most commonly used VR device currently. So Meta has a device called the Quest 2. And we can see the Quest 2 has both the headset and hand controllers. So hand controllers are also something to think about for accessibility, the same way that we need to think about a computer keyboard being able to be used on a website. With VR, we need to think about how we can do things with these hand controllers. And you can see the hand controllers have a thumbstick and then 3 buttons on the front of the device, as well as some buttons on the side and bottom of the device. So this is just all new stuff to think about for accessibility. Because these have to be held in certain grips, we need to consider different types of hands, and maybe people that can only use one hand, or maybe someone wants to be able to do VR but use no hands. That should all be possible. And we need more work in accessibility for VR to make that possible. The other piece that you may have heard of is this augmented reality. And so this is an interactive experience of a real world environment where the objects that reside in the real world are enhanced by computer generated information. So in this example, we have Pikachu standing on a street corner. It's a real New York City street. However, Pikachu is, a virtual character that we can see. So this is an example of augmented reality where we're combining the camera of the real world with virtual objects. And I wanted to mention this is another experience I've had in VR, which was cool. That's sort of like AR. I was able to travel to my grandfather's home in South Carolina in the United States. My sister and I had never been there in real life, but in virtual reality, augmented reality, we were able to go see the house. My father, my sister, and I, all wearing these headsets, traveled to see a house that's part of our family that I'd never seen. So this is something also exciting about VR. We can do lots of new experiences. So now I want to show some things that are being done for accessibility currently in VR. Meta or Oculus has a set of 9 checks that cover some important areas of functionality. And then my company has been working to help create more checks and considerations. And these would all be ones that should be similar to things that we have in the Web Content Accessibility Guidelines. But of course, there's going to be other things that are unique to virtual reality that we're going to need to consider for accessibility. Let's look at some. Okay, so just like we're having UD Talk today provide subtitles for when I'm speaking, when we have a virtual reality experience, we need to provide subtitles for dialogue and sound effects. And I have a pretty cool example here of what can be done using captions and language. So this is an example from something called AltSpace, where we had a person visiting us who was speaking German, and also we had Makoto Ueki-san visiting us speaking Japanese, and we were able to read the captions for that presentation inside of the experience. Let me show you a demo.
Also wir sprechen hier Deutsch und es wird auf Englisch übersetzt.
Yeah, that looks good.
Ja, und es ist sogar korrekt. Ich sehe es in meinem eigenen Text unten.
I'm speaking Japanese.
It's working.
おはようございます。
It's working.
今日はトーマスに誘われてここにやってきました。私たち日本人は英語を話さないので、いつも言葉の壁に悩まされています。でも、この技術を使うと、その壁がなくなり、より多くの皆さんとコミュニケーションが取れそうなので、とても感激しています。今日はありがとうございました。
So this was really a cool experience. And one of the reasons why I showed AltSpace for this example is, unfortunately today, very few VR experiences have captions. So this is something that we want to start seeing more of, the same way that we expect to see captions now on YouTube videos and television shows. We want that to be possible for virtual reality. So that was one where it is working, and a great example to learn from.
I'm speaking.
The next thing we should think about, which this is also similar to WCAG, text and in-app controls and elements necessary for an app progression should be clearly legible. So clearly legible is not defined as a certain font size or certain color contrast, but we can kind of consider or think about this VRC to be something similar to what we use to test regular application accessibility. So in this example from Oxford Medical Simulation, we have a set of buttons that can be used inside of the experience, and there's text for those buttons. So much how like we would test with color contrast checker tool on a desktop application, we can do the same thing in VR and see that the text here for this particular experience is very difficult to read because of the light colors and the opacity settings of the UI. So what we want in the future is this ability to change the UI in VR to be larger and have good contrast. This is a quick demonstration from a developer named Voxel Kai, who I met in Japan. This is to show one interesting thing in VR is we can allow people to simulate having different vision disabilities. And this is showing when I put the glasses up to my face in virtual reality, the blurriness of the room reduces. And this is showing a Japanese eye exam schedule and information. And so this is just a really cool experience where you can't do that as efficiently in a real software application. But in virtual reality, we can give people these experiences and, you know, help people learn and understand about these different eye conditions. And then last, this will be a little hard to know without using the experience, but I wanted to say a exciting new development for Meta is they have an accessibility settings menu inside of the device. And each month, new operating systems get released, maybe more than a month. But in each update, there have been more and more accessibility features. And one great feature here is having larger text in the user interface. So I'm able to configure that now. Now this one I think is a really interesting requirement. It says we should provide clarity and direction to the user through a combination of visual, audio, and/or haptic feedback, instead of relying on one form of feedback. So basically, we're very familiar with using visual notifications in user interfaces, but using audio and touch or haptic feedback is not as common. But as we'll see in this example, it makes the experience much better. And when we think about accessibility, it provides the same information in multiple ways. So this is always good for accessibility when we have, you know, many options to access information.
So it doesn't prompt you to do this. You just do this through exploration. But when I hold this razor, I actually have a vibration going on the left-hand controller. And I can do a gesture of moving the shaver over my head and removing my hair. And the whole time, this razor is vibrating because it's electric.
So what I was trying to show there is that because the hand controller was vibrating, I could know that I had picked up something that was an electric shaver. I could hear a buzzing sound of an electric shaver, and visually I could see the electric shaver. So this is the example of one item in VR that's using 3 types of output information. But we need many more examples. Applications should provide an option to be played with one hand and/or controller. So this is, again, showing that for VR, a lot of times it's very important, or games have an assumption that you're playing with 2 hand controllers. And so this requirement is to allow a solution where someone that only is able to use a single hand controller can still do everything in the experience.
So one possible tip for one-handed players would be to use the remapping in the OS to remap the A button to either the left stick button or to the left bumper, so that you can keep your thumb on the stick the whole time and just press the bumper for the selections, or maybe you have your finger on top of the stick and then press the stick for the selections instead, and that way your finger is on the stick and ready to react to the enemies at any given time.
And this is Josh Grisdale, who lives in Tokyo, speaking about how to remap a arcade game for one-handed gaming, but the same idea applies for VR, that we need some type of screen to allow different button presses or actions to be mapped to a different set of actions. And this is called input remapping. So that's something very big in VR, is to support allowing that input remapping. Another experience, which I will save just in the presentation materials, but Half-Life Alyx is a famous game in virtual reality, and it has a rich set of settings for setting one-handed controller gameplay. So this is talking about number 5. We should have the ability for applications to edit their display settings, such as brightness and contrast, to accommodate visual needs. So this is one, too, that we've been waiting to see different examples. I'm happy to say there's new support for changing the contrast of the Meta Quest from the accessibility settings. So I think this is one interesting place, that now that the device itself has a place to set the contrast and brightness, applications can consider how to provide accommodations based off those settings. So this is showing still that same example of Oxford Medical simulation, but just showing we want to test the colors that's used in VR, and potentially be able to change the colors of signs in VR with an accessibility setting. And this is a screen demo of me going to navigate to accessibility inside of the Quest. And we can see under vision, there's an option to change the contrast. And as I move this dial back and forth, the background of the screen becomes either solid black or it has a gradient. So that's just a really cool feature that now makes the menus a lot easier to read in the headset. And one other just cool area to show there, that this only works in certain countries at this point, but there's support for voice commands. So this is something we think will be really important for accessibility in VR, is anything that you could do with the hand controllers could also be made available via voice command. So there's rich support for this, and my company's building some demonstrations related to voice commands right now. This one is saying applications should either provide color blindness options or use other techniques for easy visual distinction. So this is to show a game called Beat Saber. So the key thing here is that this application, this Beat Saber is probably the most played game on the VR devices right now. But Beat Saber uses red and green typically to communicate information. And so what was cool in this game is you can change the settings. And here we've changed it to yellow and blue. Yellow and blue are often a color combination that people with color blindness can easily distinguish. So this is showing how the game can be adapted, and actually changing the entire background to match the colors is a really cool experience of how to do support for color blindness in VR. And here is another quick demo from working inside of that classroom from Voxel Kai. But here you can actually simulate what the world looks like with different types of color blindness, or an attempt to. So this is picking up I think a milk carton. And we have the color vision set to what it would seem like if you had proto-anomaly. Here's deuteranomaly, and there's also tritanomaly. So pretty cool, like that. Again, in VR, we have a way to, on the filters of the glasses, turn that on, and that might be a way to test experiences in VR for accessibility for this requirement. Like try to play the game with the Protanopia red-green filter on and see if you can complete the steps. Number 7, applications should provide the user with the option to rotate their view without physically moving their head or neck. And so again, this is something that in VR, because it's information presented in 3 dimensions, sometimes there's assumption that we're going to turn around in our seat and look behind us, or we're going to stand up and sit down. And so this is talking specifically about turning our body without physically needing to move our head or neck. So these are some examples of how this can be solved in VR. There's something called snap turning, which requires a hand controller, but does not require head movement. There's gaze control, which requires slight head movement. Voice control, that does not require physical movement. And then eye tracking control, which does not require physical movement. So let me show you one example of a solution. This is the snap turning solution for this.
Hi, this is EcoEntry, and I would like to demonstrate what snap turning looks like. So, I am in a virtual reality environment right now, and I am surrounded by various objects around me. Now, there is a blue bird on the left, and let's say I want to look at it. What I can do is turn my head physically towards the left and see the blue bird. But what if you don't want to or unable to turn your head physically? What you can do is to use this hand controller. So if you push the thumbstick to the left once, you can turn your view without turning your head. And if you want to rotate your view back to straight, you can push the thumbstick to the right. Right now, the rotation angle is set to 45 degrees. And this is what snap turning looks like.
So I like that video because we wanted to make sure you can see the idea of picturing the full body wearing the headset. And this solution allows someone to not have to physically move their head, but in virtual reality, still move the view. So this is something we like to see implemented in every VR experience. But right now, this is something a developer would need to code specifically into the experience. Applications should support multiple locomotion styles. So locomotion is how you move in a VR experience. So this is an example from AltSpace where I'm going to teleport and move by pushing my hand controller, and I quickly jump to where I'm asking to go. But I can turn on a different mode. And now you'll see that the camera actually animates and moves to walk. That's called dash. Blink, it's actually closing the eyes and opening the eyes. So it's doing slightly different things when we try to move around in VR. And so why is this important? A lot of the movements in VR can cause motion sickness for people. And one of the solutions is to provide multiple ways to move in VR. So the same way we have multiple ways in WCAG, thinking about ways to like search for information. In VR, we need multiple ways to actually move because for some people, certain movements will cause sickness. The blink one is an interesting example of, it's the idea of like closing your eyes, moving, and then opening your eyes again when you've reached the new location. From tests we've done with people we've met in VR, that seems to be one of the locomotion styles preferred by users. This is to show something called the locomotion vault. And the main point of this is there's, at least 50 different types of locomotion that can exist. So this is an interesting place if you're interested in this area. Looking at the Locomotion Vault, they have demonstrations of all these different types of locomotion. We want to provide a user setting to perform all interactions and access information from a fixed position. So this is to show an example of a game called Vacation Simulator, where currently the person is standing and actually turning their head, rotating, even at some point walking in the experience. But here is the same person playing the experience in a seated position. So this has been a big thing in VR, to not make an assumption that someone can, say, walk 2 feet to the left or reach all the way down to the ground. So this is a requirement to think about making it a consideration that, for example, someone may be in a wheelchair playing virtual reality. Someone else might not be able to rotate or reach very far. So these are all things that need to be considered even more in virtual reality, because there's the idea of like reaching out and grabbing things in a lot of the experiences in VR. Here is kind of a gross video of a frog dissection. And again, this is one where technically you would have to reach and control instruments to do this frog dissection. But what we would want for accessibility is to be able to do the dissection either with voice commands and or with limited range of movement. I should still be able to complete the frog dissection, for example.
This is a 360-degree camera.
You travel with this?
Yeah, I already traveled to Hawaii with this. When I showed the picture to my friends, they were so surprised.
What did they say?
Oh, what? Unbelievable.
Unbelievable.
Yeah.
So how will this change life for seniors?
Most of the senior people cannot move, travel, right?
So this lets them.
Those who have lived for 80, 90 years, there aren't so many things they haven't personally experienced. So when they see the VR, using this device takes them to a different place right before their eyes. They were extremely excited. I saw people stand up who don't normally stand up, who then start walking. It was so shocking.
One of my favorite parts was when you were pushing the fellow around on the wheelchair and you had the little segways on your feet. It seemed like that really brought you a lot of joy.
I'm sure it's fun for him, but I might be enjoying it the most.
So I wanted to sort of end from the use cases here for VR, just to mention that I do think it's quite exciting how many senior citizens actually really enjoy virtual reality. So this is something I've even experienced with my own father. He has a Meta headset and he probably plays it as much as I do. And so I think this has been a cool use case for VR, is working with senior citizens so they can, for example, travel the world and see places that they might not be able to travel to physically anymore. And so again, I think wanted to end with saying that's one of the reasons too, I think these accessibility requirements for VR are so important, because with, again, with the elderly and aging population, they're going to have the same needs for these accessibility features in VR. And let's jump to here. Wanted to end with just mentioning that, had to go through a lot of information here today, but we host 3 different meetups through Equal Entry. With Ueki-san, we're doing Ali Tokyo meetup. In New York, we're doing Ali New York City. And in VR, we're doing Ali VR. So Ali VR, if you're really interested in this topic, is the one to sign up. We specifically have people come and present only about new accessibility features for VR at that meetup, and would love to see you all there. And now we're in the time for the Q&A. Did we have any questions?
All right, Thomas, thank you so much.
Yes, thank you.
Are you watching the web browsers to see UDTalk captions?
Not live, not right now, no.
Could you check the Google chat? I sent you the URL.
Okay, sure.
You can open the chat on your browser, and I'm gonna speak Japanese.
Great, I'm just pulling that up right now.
Are you ready?
Yes, I've got it.
So can I speak Japanese?
Yes.
はい。それでは、ここからは私は日本語を話して、トーマスは、ウェブブラウザーで UD トークの翻訳を見て、私が何を話しているのか理解して、トーマスは英語を話す。僕は日本語を話す。お互い UD トークの翻訳結果を見ながら会話をするというチャレンジをしてみようと思います。これはトーマスのブラウザー画面のようですが、翻訳がされて
いや、来てますかね。右目でトランスレーションオンになっているので、ね、はい。
はい。では、佐野さん、何か参加者の皆さんから質問は届いてますでしょうか？
はい。質問は今のところ来ておりません。ですが、感想はいくつか来ております。はい、ちょっとお待ちくださいね。はい。感想をご紹介しますね。VR のミートアップの日本語で話しても英語の字幕が顔の上に浮かぶ、あれ、現実世界で欲しいなという感想がありました。はい、スマホの次はそういう方向に行くのかなというコメントがありました。はい、これ難しいですね。一旦ご紹介をしてしまって大丈夫ですか？はい。はい、あとはですね、ゲームのアクセシビリティについてもいくつか感想が来ております。キャプションにどの方向で誰が喋っているか表示が出るもの、あれが、興味深いという感想と VR ならではのアクセシビリティだねというコメントが来てました。あとは首を動かさなくてもいいというのに共感をしている人もいらっしゃいました。はい。
はい、ありがとうございます。では、トーマスに質問です。VR のアクセシビリティのミートアップ、次はいつ予定されてますか？どんなテーマでしょうか？トーマス。
So the next VR meetup is scheduled for this summer. The next theme is going to be work we're doing with 3 developers from India and the XR Access working group. And it's very exciting, much like the demo of the snap turning. So thank you for the comment on being able to understand why that's important for accessibility. We built an example for snap turning to share with developers, but in this summer, we will have an example, 3 different developers providing accessibility solutions for VR. And we hope people can come. And if you're working on something in VR, we hope the code could help make it easier for developers to make accessible VR.
はい。はい、ありがとうございます。今僕も UD トークの 翻訳結果を見ながらトーマスが言っていた内容を理解しているところです。はい、とても楽しみなミートアップになりそうですね。それからもう一つ、東京でもミートアップを始めたということですが、次回の予定が決まっていたら教えてください。トーマス。
Yes, so very excited for the meetup in Tokyo. I can show you our English page and our contact pass page. But for those of you all in Japan, this meetup is Ali Tokyo and has been great working on it with Makoto-san. So we have the next talk, we have today's event just marked because, hey, we're happy about GAD Japan. And the next event will be inclusive design for a digital world. Regine Gilbert is coming from New York City, and she actually has a book coming out into Japan. So her design book has been translated into Japanese. We'll be using UD Talk there, just like this. She will be speaking English, and we'll be using UD Talk for live translation. And so here's our page on Compass. Makoto.
はい、ありがとうございます。では、ちょうどお時間になりましたので、ここでトーマスさんのセッションは、終わりにしたいと思います。トーマスさん、ニューヨークの早朝にプレゼンテーションしていただきありがとうございました。
ありがとうございます。
ありがとうございました。
Thank you, Thomas. See you.
Thank you very much.
See you soon.